So today's the topic which we are going to discuss is your Boolean algebra. Boolean algebra. So this is the topic for the day. Now, what's its history? So actually, in 1854, there is a scientist called George Boole. So he is actually the one who has given this particular algebra. So what he said that and that it has actually given investigation of the laws of thought on which are founded the mathematical theories of logic and probabilities. So what we are actually discussing in digital is based on some logic. So it's not a random decision कि आपने कुछ भी किया वो randomly आ गया, नहीं, उसके पीछे कोई logic है, some probabilities are there. उसके basis पे इन्होंने जो सारा है, the entire discussion is being there called Boolean algebra. So it's a very interesting thing. And it is the good thing about this particular kind of algebra that you are able to solve all the numericals, all the problems, all your day-to-day problems using this particular algebra. So there is a technique to do that. We will be going to learn that. So one more thing about Boolean algebra is that it is convenient and systematic way of expressing and analyzing the operation of logic circuits. Okay. So whenever I'm using this term, that systematic way of expressing, analyzing the operation of logic circuits, then we will use Boolean algebra. तो ये तो जो बात हम कर रहे हैं, this is entirely about theory and all, but actually Boolean algebra है क्या, or where we are actually going to use that in simple terms that I'm going to discuss right now. You know that we are having switching circuits. Either they are on or they are off. So when a circuit is on, it is giving you some voltage level. And when circuit is off, then also it is giving you some voltage level. And to be precise, on we will classify it as 1, logic 1, and off we will classify it as logic 0. So suppose you have assigned a certain voltage level that from 3 to 5 volts, if you are getting this at the output, we can say that system is on and this is 1. And if you are having voltage from 0 to 1 volt, then we can say the system is off and it is being assigned logic 0. Okay. And in between, if your voltage level is there, then we can say this is disturbed state, or we can also say this is called invalid state. Okay. So suppose you are having OR gate like this. This is a symbol, logic symbol for OR gate. It is having inputs like A and B. Output is Y. So here you can see A and B are inputs. So you are giving 0, 0. So 0, 0 means you are giving a voltage level which can be treated as 0. And 0, 1, 1 means the voltage level in this range. If you are applying voltage level in this range, so here you're getting 0 output, 1 output, 1, 0, your output is 1, 1, 1, your output is 1. So that means if you are applying this sort of outputs, you are getting output as high, output is high, output is high. So high means you are getting certain voltage level which fall in this particular range, 3 to 5 volts. Okay, so that's all about your the basic things. So when we called Boolean algebra, then we are going to use this particular terminology. Now, if you are having a one system, then it's fine. But when you are having more than one inputs, then you are definitely going to give them variables. Suppose it is having three inputs, then third variable is there. So we are actually assigning certain variables to the system, like input variables are A, B, and C, and your output variables is Y. So we are actually assigning these variables like A, B, C, and these are your input variables, and Y is your output variable. Now, a variable can have two values. A is equal to 0 or A is equal to 1. At a time, a variable can hold only two values. At a time, only one value. Either it can be 0 or it can be 1. Okay. So it means either A is off or A is on. Similarly, for B, we can also say that B is on or B is off. For C, we can say that C is on, C is off, like that. Okay. Now, one more thing in this regard, that same variable can be expressed in two different ways. A, A bar, B, B bar, C, C bar. So bar means complementing. We are actually complementing that particular variable. So suppose A is 0, then A bar is going to be 1. If B is 1, B bar is going to be 0. If C is 1, C bar is going to be 0. And vice versa. If A is 1, A bar is going to be 0. If B is 0, B bar is going to be 1. If C is 1, 0, this is going to be 1. If we want to express this in terms of Venn diagrams, you can see if this is A, if this is A, then this is A complement, or we can say A bar. So that means A intersection A complement is equal to 0. That means there is nothing common in between these two. We are actually intersecting these two. So there is nothing common between these two. So if we are going to unite them, union of this is going to be 1. So your entire space is going to be like this. If you are going to unite, if you are going to intersect them. But we are not going to do this thing. We are only keeping our focus on this particular thing. So I hope you get some idea about what is going to be Boolean algebra all about and why we need Boolean algebra and all. If you have any doubt, the forum is open. We can have discussion on this.
No, sir. No doubt.
Fine. अभी तक समझ में आ गया?
Yes.
Okay. Now there are certain rules. There are certain rules. Rules for what? Rules of Boolean algebra, conventional algebra. You know that if A into A, then this is going to be A square. Yes or no? If A plus A is there, it is going to be 2A. And if 1 plus A is there, it will be going to remain as 1 plus A. So this is nothing but the algebra which you are doing till now. This is called conventional algebra, the algebra which you are using till date. Now, coming towards Boolean algebra, what are the unique things about Boolean algebra and how we are actually going to use it? So when we are actually using Boolean algebra, there are certain things which you should notice. The first thing is symbols used in Boolean algebra do not represent numerical values. It means if I'm using A, then it is A. If I'm using A bar, it is A bar. It is actually variable. It is actually variable, or we can say symbol. It can be given some values like 0 or 1, but it does not have any numerical significance. They are just symbols. Second, arithmetic operations cannot be performed. Arithmetic operations cannot be performed in Boolean algebra. Here you can see I have performed some arithmetic operations, but they cannot be performed in Boolean algebra. Now coming towards the third thing, if you are having any variable, then only two possible values are there. Either it can be 0 or it can be 1. So this is the possibility. If you are having any variable, either it is having 0 or it is having 1. There is no other possibility. Okay. So this is the sum of the aspects regarding Boolean algebra. Now I will be discussing some other aspects in that. One of them is various logic operations. So if I am saying this various logic operations, then what are the various logic operations that are possible? So I'm going to make a table so that you can get a better idea of the things. Okay, so in this we are having 4 different things. One is serial number, then logic gate, then logical expression, then Boolean expression. So these are the things we are having here. Okay. So let's start the discussion. What can be done here? So the first logic gate, suppose we are already aware of this. This is called NOT gate or inverter. So what is its operation? What is going to be the operation of this inversion? That means whatever it is the input, it is going to invert that. So Boolean expression corresponding to that is y is equal to a bar. So if a is 0, output is going to be 1. So the symbol for this is, and this is going to be the input A. So your output is like this, complement of input. So if A is 0, output is equal to 1. If A is 1, output is going to be 0. Second kind of gate, you are already familiar with that, is AND gate. And what is the logic involved in that? So logic is logical multiplication. Logical multiplication. So that means if you are having a NAND gate and AND gate, and these are your inputs, this is your symbol A and B, then your output is going to be multiplication A dot B. Okay. Then third kind of gate in this category is OR gate, and here we are having logical addition. Logical addition. So this is being given by A plus B. Symbol you already know. This is the symbol for your OR gate, A and B, and this is your output. The next kind of gate is NAND gate, And simply words, we can say not of AND gate. That means inversion of AND gate. So its symbol is simple, but we are putting bubble here. So this becomes A, B, and Y. Similarly, we are having NOR gate. So it is not of OR, and its symbol is A plus B and complement of this. So symbol is again like this, and we are putting bubble here. So your OR gate is there, and we are putting bubble. That means we are actually inverting the OR gate. So next kind of gate is Zor Gate XOR gate. So it is being used for addition as well as subtraction. So its symbol is like this, and symbol is, and last kind of gate is exclusive NOR gate, and we can say this is not of XOR gate. Y is equal to and its symbol is like. So these are the certain logics that are involved as far as your devices are being concerned. Now, there are certain rules which need to be followed when we actually work with your Boolean algebra. So let's discuss those rules. Rules in Boolean algebra. So the first rule which we can be using is variables are either high or low. Okay, this is the first rule. That means if your variable is a, then it can hold any one value at a moment. Either it is 0 or it is 1. If you are using a bar, it can also have two values. Either it can be 0 or it can be 1. So at a time, a variable can hold only one value. This is the first rule. So if your b bar is equal to 1, then your b is equal to 0. This is the second rule. That means at a variable can hold only one kind of value. It's not like that if you're having a is equal to 1, then ar is equal to also is equal to 1. So at a time, one variable is having only one value. So a is equal to 1, then a bar is definitely going to be 0. And this is not accepted. This is the rule number 2. Third rule is whenever we are using ORing operation, it represent plus. Okay. And whenever we are using ANDing operation, it represent multiplication, dot. Okay. Now, on the basis of that, we are having certain laws. We are having certain laws. So what are them? We will be discussing them one by one. Boolean laws. So the first law, which you have used in other kind of mathematics also, commutative law. Now, what is that? It says that A dot B is equal to B dot A. That means if you change the order in which your variables are represented, there is no difference. they are one and the same. Similarly, A plus B is equal to B plus A. So it does not have any impact on the output. Here you can see, suppose you are having a AND gate, and this is your A, this is your B. So then what is your output? Your output is going to be A dot B. But if you change it as B and A, then also your output is going to be B dot A. So it does not have any impact on the output. So that if you change the variables, it does not have any effect on the output of a logic circuit. Your output will be same. So this is the first law. Second law, which is very important, is called associative law. So what does it say? A dot B dot C is equal to A dot B dot C. Or if it is for OR operation, then we can say that A plus B plus C. So it does not have any impact. So it is one and the same thing. So if you want to implement this in terms of gates, then you can say this is your A dot B, and this is your C. So here you are getting A dot B dot C. And similarly, if you doing in other way, this is A and this is B dot C, then also you are getting A dot B dot C. So this is your associative law. It says that whether you perform the operation in the one way or the other way, the result is going to be same. There is no impact on this. Now there are some more laws. I will be discussing them one by one. So we have discussed associative law, we have discussed commutative law. Another law in your Boolean algebra is distributive law. So what does it says that? It says that A dot B plus C is equal to AB plus AC. So it's called distributive law. So it's one and the same. It does not have any impact on the output. Either you can describe in this way or this way. The answer will be the same. Now, there are certain other laws which are being classified in this category. They are called AND laws. So what are those? This is your Boolean variable. This is 0. So this is going to be 0. If A dot this is equal to A, then A dot A. If you are multiplying two variables, then output in conventional algebra it is A square. But here it is not the case. Here it is A. Similarly, if A dot A bar, A complement, then this is going to be 0. This is going to be 0. And why it is so? Suppose A is 1, then this is 0, then 0. If A is 0, this is 1, then this is also going to be 0. So they are complement to each other. So their product is definitely going to be 0. So product of a number, a variable and its complement is always going to be 0. Whether it is C dot C bar or whether it is D dot D bar, whatever it may be, it is going to be 0. So these are AND laws. Then another category which I am going to discuss is OR laws. It says that A plus 0 is equal to A, and A plus 1 is equal to going to be 1. And how it is 1, I will discuss. Because this is a Boolean algebra, so A can have two values. Either it can be 0 or it can be 1. Suppose A is 0, then it is 1. Suppose A is 1. Now you can say 1 plus 1 is equal to 2. But no, this is not the conventional algebra. This is Boolean algebra. So either your machine is on or machine is off. So if A is equal to 1, then machine is on. So on plus on, that means machine is on. Your system is on. So double on means nothing. Double off means nothing. So on means on. So A plus 1 is definitely going to be 1 only. Your machine is going to be on. Then A plus A is equal to A, not 2A. Okay. Then a number and its complement is going to be, sorry, a variable and its complement is going to be 1. Why 1? As discussed already, if A is 0, this is 1, 0 plus 1 is 1. If A is 1, this is 0, 1 plus 0 is going to be 1. So these are OR laws. Then one more law I am going to discuss with you is A double complement is equal to A. That means if you complement a variable twice, then it is the number itself. There is no variation that if you are doing like this or that, you are going to get a different answer. No, you are getting the same answer. So on the basis of that, there are certain Boolean theorems, and you are going to solve it of your own. Yeah, I will be discussing them in the class, some of them, but it's important you will try them of your own so that you get a better understanding. So I will be putting it in the WhatsApp group. So from there you can do of your own their solutions. Yeah, it is readily available on the internet. From there also you can do that. So that's all for the day. So today we have discussed about your importance of Boolean algebra and its theorems. So if you have any doubt, you are free to discuss with me.